Hi everyone, welcome back to the channel. So in this video, we will learn about one important concept of wave mechanics, that is quantum mechanics and atomic structure, that is Bohr's model of the atom. And based on this Bohr's model of an atom, we shall look over a simple derivation for the mathematical expression that furnishes details of radius of the orbits in which the electrons are revolving around the nucleus. Okay, so firstly we shall look over about the Bohr's model of the atom. Before to the Bohr's model, simplest model for explaining the structure of atom was proposed by Lord Ernest Rutherford. But the one problem with Lord Ernest Rutherford's model of atom is the Rutherford's model was unable to explain the emission of electromagnetic radiation by a material, and thus therefore it was unable to explain the existence of spectral lines for the even for the simplest atoms such as hydrogen atoms, and thereby the Rutherford's model was unable to explain the hydrogen spectrum. And in order to get a theoretical explanation for the existence of the spectral lines and their regularities, as also to solve the conflict between the conclusions of conventional mechanics and the law of electrodynamics, Bohr in the year of 1913 put forwarded a theory to improve upon the Rutherford's model of the structure of an atom. And the theory proposed by Bohr is purely based upon the principles of Max Planck about the absorption and emission of radiation by an electron. And one more drawback is there for Rutherford's model, that according to the Rutherford's model of an atom, electrons revolve around the nucleus in circular path and successively they lose the energy. This is the assumption given by the Rutherford, but practically which is not going to happen, right? So in order to overcome all these limitations, Bohr proposed a very satisfactory theory in the year of 1913. And now we shall look over the postulates of Bohr's atomic theory. The first postulate is the electrons in an atom revolve around the nucleus only in certain selected circular orbits. As long as the electron remains in a particular orbit, it neither loses nor gains energy. In other words, the energy of an electron remains constant in a particular orbit. In an atom, the electrons revolve around the nucleus in certain selected circular shielded paths, and those shielded paths are called as orbits. This is the first postulate that comes under Bohr's model of the atom. And here the orbits or the shielded paths means their energy will remain constant. When the electrons are staying in those shielded paths, when they are present in such orbits, their energy will remain constant, and thus there will be no loss of energy for an electron even though it is continuously revolving around the nucleus. This is the explanation given by Bohr, and that will be summarized in the second postulate as, since the energy of each orbit is quantized in the sense fixed. So when the energy of each orbit is fixed, the energy of the electron which is present in that particular orbital will also remains constant. So this indicates there will be no loss or no gain of energy by an electron when it is revolving around the nucleus. And as we said, the energy of each orbit is quantized, that is fixed. We can also call the energy orbitals, the orbits in which the electrons are revolving, as energy shells or energy levels. The orbits can be called as energy levels or shells, and since the energy of those orbits will remains constant, we can also call these orbits as stationary states or stationary levels or stationary energy states. Okay, so these are the different names we can give for the orbits in which the electrons are revolving around the nucleus, and those energy levels will be given at the symbols K, L, M, N. So this notations have been given based on the position of the orbits from the nucleus. So the shell, that is K shell, which is present nearer to the nucleus, is given with the number 1, and L shell will be given with 2, 3, 4, and so on. Like this, the symbolization have been made for the orbits in which the electrons are revolving around the nucleus. And as I said, the energy of the orbits in which the electrons are revolving around the nucleus is constant. Hence, we call the orbits as stationary levels or stationary states. Next, the postulate is, based on the above two postulates, we can say that the motion of the electron is so much restricted. So in such a way, Bohr argued that the motion of the electron in a given orbit is restricted, that they can have only such or selected orbits in such a way that they should have the angular momentum which is an integral multiple of h by 2 pi. This is the third postulate set by Bohr under his model of the atom. On the basis of third postulate of Bohr's model of atom, we can say that there is no liberty for the electron to occupy in whichever the orbit it wants. The electron should occupy in those orbits only, those energy levels only, provided the angular momentum of that particular electron is supposed to be the integral multiple of h by 2 pi. The angular momentum, that is mvr, mass into velocity into radius, right? So the angular momentum should be equals to integral multiple of h by 2 pi. Here the value of n will be 1, 2, 3, 4. That means the value of the shell number. The shell number will be inserted over here so as to get the angular momentum, and that should match with the practical angular momentum of that particular electron. Then we can say that that electron belongs to so and so the energy levels. This is purely in accordance with third postulate of Bohr's model of the atom. So when the value of n is an integer, angular momentum of electron should be the integral multiple of h by 2 pi. So we will get the whole number values as, if n is equals to 1, we used to get mvr is equals to h by 2 pi. If the value of n is equals to 2, we get mvr is equals to 2h by 2 pi, or simply h by pi. If n is equals to 3, mvr is equals to 3h by 2 pi. If n is equals to 4, we will get 2h by pi. So like this, we will be getting the values of angular momentum of the electron, and that will say that the angular momentum of the electron is always fixed. That means quantized. That's about the third postulate of Bohr's model of atom. The next postulate is, as per the fourth postulate, the electron is liable to absorb or emit the radiation, provided this can happen only when the electron jumps from one energy level to another energy level. This may happen between lower energy level to higher energy level, or from higher energy level to lower energy level. We know that if the electron jumps from lower energy level to higher energy level, we call it as excitation of the electron. And similarly, if the electron jumps from higher energy level to lower energy level, we call it as de-excitation of the electron. And one more thing will comes to our mind. Okay, fine. When electron jumps from lower energy level to higher energy level, or higher energy level to lower energy level, so energy factor will be there. If you consider the de-excitation of the electron, because the electron in excited state is highly unstable, it always tends to stay in a stable lower energy state. So when electron is coming back from excited state to the ground state in one or more jumps, that means, say for example, if the electron is present in the third energy level, that is in M shell, and it may take transition either to the second level, or it may take transition to the first level, right? So that's what we said. It may reach the ground state either in one jump or in more jumps, right? So when the electron jumps from higher energy level to lower energy level, it can only release some, or else when the electron can can move only to a certain energy level, and that will release a quantum of energy, and the jump of electron to whatever the energy level is not permitted. That means the excitation and de-excitation of electrons between the energy levels is also restricted. The electrons can take transition only to certain energy levels only. That what we call as allowed transition of electrons can only occur. That is purely in accordance with the fourth postulate of the Bohr's theory. So according to which the electron can jump in such a way that it can jump from one level to another level, which are the allowed transitions, and during this allowed transition the electron will release, this is in particularly to the de-excitation of the electrons, the electron will release one quantum of energy, and that is equals to h nu, that is according to the Planck's quantum hypothesis, that is E is equals to h nu, provided nu is the frequency of the radiation. Okay, and the value of h nu, that is the energy released by an electron during its de-excitation, should be equals to the difference in energies between the two stationary states. Okay, and evidently we can say that the value of the frequency of the emitted radiation will be different for each quantum. That means depending upon from which level to the which ground state, that means whether the electron is jumping from or taking de-excitation from third level to second level, or from second level to first level, depending upon that the amount of energy released by the electron will get vary. Say if the electron took transition from second level to first level, the difference in energy, that is E2 minus E1, that what we can take it as delta E, that will be equals to h nu 1. Suppose if the electron take transition from third level to first level, the difference in energy will be E3 minus E1, that will be equals to delta E, and that will be taken as h nu 2. Like this, the energy differences will be calculated, and that will be always influenced by the Planck's quantum equation, that is E is equals to h nu, and these are in accordance with the Bohr's theory of atom. So when we are discussing about the third postulate of the Bohr's atomic theory, we have said the m is mass of the electron, v is the linear velocity of the electron, and r is the radius of the orbit from the nucleus, right? So radius of the particular orbit. We need to know the exact numerical value of the radius of the orbit in which the electron is revolving around the nucleus. So now we shall proceed further for deriving the expression for the radius of the orbit in which the electron is revolving. Okay. Now let us continue with the derivation of expression for nth orbit of an atom. Okay, so here we have taken a pictorial presentation of a hydrogen atom, which is the simplest atom, which containing only one proton and one electron. So here let me consider the charge which is present on the nucleus of the hydrogen atom. The charge present on the nucleus of the hydrogen atom will be taken equals to Ze, provided Z is the atomic number of the atom, provided the hydrogen atom is having an atomic number of 1, and hydrogen like species such as lithium and helium can also be considered. And electron, which is having a charge equals to E, especially minus E, which is revolving around the nucleus with a radius of r and having a velocity of v, provided the m is the mass value of the electron. We know that the mass value of the electron is 9.1 into 10 to the power of minus 31 kg. So according to the classical mechanics, the electron which is revolving around the nucleus will experience two kinds of forces. The electron will experience centripetal force. The centripetal force will pull the electron towards the nucleus of the atom, and that centripetal force is given as Ze square by r square. So let me consider this as equation number 1. So when the electron is revolving around a when electron is revolving around the nucleus in circular path, not only the centripetal force which pulls the electron towards the nucleus, the electron will experience the centrifugal force also, which take the electron away from the orbit. And that centrifugal force which is experiencing by the electron which is revolving around the nucleus will also be given as mv square by r. Let me consider this as equation number 2. Provided the electron is not coming towards the electron and not going away from the orbit. That means if this has to happen, the centripetal force of the electron should balance with the centrifugal force. Because of this reason only, the electron is continuously revolving around the nucleus in a specific position without pulling towards the nucleus and not going away from the orbit. So by considering this factor, we can compare these two equations under this particular classical mechanics. So when you compare equation 1 and 2, it will become ze square by r square, that's equals to mv square by r. Okay, so now we shall manipulate the equations. R and square will get cancelled, so that ze square by r is equals to mv square. So let me consider this as equation number 3. Okay, so from the postulate of Bohr's model of atom, especially in postulate number 3, that what we have discussed in previous minute, each and every electron will possess a definite angular momentum, and the angular momentum of each electron is quantized, right? So the angular momentum of electron will be taken since it is revolving around the nucleus in circular path, right? So the angular momentum of electron will be given equals to mvr is equals to nh by 2 pi. This is purely in accordance with Bohr's theory of atom. That is, angular momentum of the electron is integral multiple of h by 2 pi. Now we shall square the equation. Let me consider this as equation number 4. So the equation 4 is subjected for squaring. So we shall square on both the sides. When you square on both the sides, the equation will turn in such a way that m square v square r square is equals to nh by 4 pi square n square h square. So this is the one. But here we actually squared this equation in order to get the value of v square. So v square is equals to n square h square by m square r square 4 pi square. So this is the equation we get when you alter this equation, and let me consider this as equation number 5. And now we shall substitute this equation 5 in equation number 3. So substitute 5 in 3. So on substituting, the equation will turn ze square by r is equals to m into n square h square by 4 m square r square pi square, right? So here m and square will get cancelled, r and square will get cancelled. Right, so now the remaining things will be, so here we have one r and one m. So we actually need the value of r, so we shall manipulate this equation. So ze square divided by 1, that's equals to m n square h square whole divided by 4 pi square m r. So these are the things that remains in cancelling the terms. So now we shall take the r to the left hand side. So r is equals to n square h square whole divided by ze square pi square m and 4. So the value of r will be n square h square by 4 ze square pi square and m. Or else we can do some manipulations over here. That means we know the value of H, which is the Planck's constant. The H value is 6.626 into 10 to the power of minus 34 joules second. And the value of Z is the atomic number. For hydrogen atom, it will be taken as 1. And the value of charge on the electron is 1.602 into 10 to the power of minus 19 coulomb. The value of pi is 3.142, and the mass of electron is already said, that is 9.1 into 10 to the power of minus 31 kg, right? So, and N will be different for different atoms. That means we are determining the radius of nth orbit. So depending upon the value of n, the value of radius will change. So upon substituting all these values, that is, upon substituting all the values of H, Z, E, pi and M in this equation, the equation will get reduced as to n square into 0.529 into 10 to the power of minus 10 meters. But we know that 10 to the power of minus 10 is angstrom unit. So R n is equals to n square into 0.529 angstrom units. Or you can do much more simplification on this equation for hydrogen like species. For hydrogen atom, the value of Z is taken equals to 1. Suppose if you want to evaluate the value of radius of hydrogen like species, then we should retain the value of Z over here. And thus, this is the finalized expression that we can use for determining the radius of any orbit. If the value of n is equals to 1, that is K shell, and that K shell is also called as Bohr's orbit. Okay, and if it is 2, we used to call it as second Bohr orbit. That is, n is equals to 1 is first Bohr orbit, n is equals to 2 is second Bohr orbit, n is equals to 3 is third Bohr orbit. And if n is equals to n, that is called as nth Bohr orbit. Like this, the evaluation can be done for determining the radius of any orbit in which the electron is revolving around the nucleus. So do focus on this particular mathematical expression, by using which it is easier to calculate the radius of any orbit in which the electron is revolving around the nucleus. And let us do some simple calculations of hydrogen as well as hydrogen-like species. For hydrogen atom, the value of Z is equals to 1. Say we have to calculate the value of Rn. Let us consider the value of n is equals to 2. That is second Bohr orbit. So R2 is equals to, the value of n is 2. So 2 square by Z is equals to 1 into 0.529. So if you calculate, 2 square is 4 into 0.529. So the calculation of these two values will be the 2.116 angstrom units. This is the value of R2. So in the same way, we can calculate for the value of n is equals to 3, that is third Bohr orbit also. For the hydrogen atom itself, Z is equals to 1 and n is equals to 3. The same expression R3, the value of n is 3. So 3 whole square, value of Z is 1 into 0.529 angstrom unit, that is 10 to the power of minus 10. So 3 3s are 9 into 0.529 into 10 to the power of minus 10, and the calculation value is the 9 into 0.529. The value will be 4.761 angstrom unit. Now we shall proceed to calculate the radius of hydrogen-like species. So let us consider helium plus is the hydrogen-like species. Hydrogen-like species in the sense the single electron system. We know that the atomic number of helium is 2 protons, 2 neutrons and 2 electrons, right? So if we release 1 electron from helium, we will be getting only 1 electron in it, and it is mentioned as 2He plus, so which is also a 1 electron system. So let us consider n is equals to 2. Same, and the value of Z for helium will be 2. Let us use the equation Rn is equals to n square by z into 0.529 angstrom units. The value of n is 2, so 2 square divided by the value of z is 2 into 0.529. And now we shall simplify this expression. 2 2s are 4 into 0.529 whole divided by 2 is 1.058 angstrom unit. That is a value of radius of second Bohr orbit of hydrogen, like species, that is helium. So we can consider one more hydrogen-like species such as lithium 2+. So lithium is having an atomic number of 3, that is consisting of 3 electrons and 3 protons. But if you release 2 electrons, once again it will remain with 1 electron. Once again it will come under hydrogen-like species. Let us calculate the value of first Bohr orbit, that is n is equals to 1, provided the value of z for lithium is 3. So let us calculate the value of R1 by using the expression n square by z into 0.529 angstrom unit. Right. The value of n is 1. So 1 divided by 3 into 0.529. So simplifying, 0.529 divided by 3. The value will be 0.1763 into 10 to the power of minus 10. That is 0.1763 angstrom unit. That is the radius of the first orbit in case of lithium. These are the simplest ways through which we can calculate the value of radius of any orbit till nth orbit by using Bohr's equation. And in the next video, we shall look over about the derivation of expression for energy of the nth orbit by using the same principles of Bohr's atomic theory. Thank you.